First of all, I want to thank everybody for being or taking time out of their busy schedules to partake in this webinar. We've had some really good feedback over the years. A lot of good information. I would say a lot of very detailed information and in-depth information. So a lot of times what we find is that watching it once probably is not doing it complete justice, because there's a lot of stuff that sometimes is a little bit more difficult to completely comprehend. So we'll see people actually watch it a few times. Anyway, for those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for not only the concrete side of stuff and the Rapid RH, but I'm responsible for our full line of wood hand meters for testing finished wood products, wood flooring, wood subfloors, things of that nature. We're going to do a Q&A, so if any of you do have questions, please type them in and send them to me. I'll get to as many of them as possible. But if for some reason you think of something after the fact, or I realize that's part of this being recorded sometimes before people are actually watching it, maybe you think of something after you're viewing it, give me a call directly. I'll be more than happy to talk with you, answer any questions, and that's now or down the road. My direct contact information is 800-624-9961, and it's extension 235. So without any further ado, we'll get on to some of the questions. Some of the questions. First question we have is from looks like Lane Carpets. Do you find it necessary to test older concrete slabs on the upper floors of an existing structure as much as it would be deemed to test new structures, especially if the older structure was not power troweled like the new structure? I guess what I would say is that I've seen some very, very bad failures that have been deemed to be moisture issues on older elevated slabs. Unfortunately, a lot of the thought process for elevated slabs in general, new or old, is that most people think that because they're not touching or having any kind of direct contact with the ground, that there's probably not going to be any issues with moisture. So I seem to see, and I'm painting a very broad brush, it seems that I see less testing on elevated decks. And I think that that's a real problem, because obviously the concrete has to flow to those higher floors, and there's ways that it does that. Sometimes it's more water, sometimes it's plasticizer, sometimes it's a combination of both. So at the end of the day, it still takes a long duration of time for that water of convenience, or that construction water, to evaporate out. And again, that's new construction. When you look at it from older structures, you have a situation where when the floor was put on there originally, even during that construction process, the floor may have not, or the concrete may have not had enough time to quote unquote dry. But because we had some different types of products back when, you had the ability to have a floor stick and have a floor perform very well. As you go through and demo the existing floor that's on there, you find out that if you test, that you're kind of unearthing a beast. The concrete has high levels of moisture with respect to today's standards, and that floor did withstand, but that is not an indication of how the new floor is going to stand up over the test of time. So I know I've given a long explanation to what, or an answer to your question. I definitely don't see a lot of people doing a full barrage of tests on elevated slabs, but I definitely would make sure that you are doing testing, because when you look at it, there are definitely issues in those older slabs that are elevated. Another question that I get a lot relating to elevated slabs relates to, especially when you're talking about concrete that's poured in steel pan decking, comes down to Where do you place the tests? How do you calculate what the 40% thickness is? So for one, I still have people that think that concrete poured in a metal pan deck, even if it's called vented pan decking, is drying from two sides, so that your calculation for your hole depth would be at 20% depth in the slab. A slab poured in the steel deck is only drying from one side. So no matter what the thickness that you're calculating based off of, it needs to be based off of 40%, drilling into the concrete 40%. So then we deal with, are we going to calculate based off the thickness at the thinner area or the thickness at the thicker area, because you have those inconsistencies in how that corrugation and that pan decking falls. Most of the time, what we will recommend is that you do your best to identify where the deepest sections are, and then drill 40% of whatever that thickness is. So if your overall thickness in the deepest area is 6 inches, then you're going to drill 40%, which would be 2.4 inches into that concrete. So the next question that I get after that is, well, how do I figure out where the deepest sections are? What I'll say is that there's a lot of times where people will use a very cost-effective metal detector that looks a lot like a stud finder that you would use on a wall, but obviously it's meant for steel, and it has a signal in the metal detector itself that is strong enough to capture where the hi-hats are at on the pan deck, but it's not so strong that it will actually go all the way down to the bottom of the 6-inch depth. So as you do that, you put it on the concrete, scan across, find the hi-hat, mark it, find the hi-hat, mark it, and then drill in between that. That seems to be one of the better ways that I've seen people doing it. Another question that I get on a consistent basis is, you always say, or it's always said, that to have the most accurate information, obviously it's a very depth-specific measurement. So with that being said, how do I figure out how thick a slab is, say, a slab on grade? So obviously, if you're talking new construction, there's construction documents, there's general contractors. They have the information for you to be able to very quickly do your due diligence to determine what the specified thickness is. Obviously, yes, I understand that based on workmanship, sometimes those thicknesses have variances, but you as the tester of the concrete, you've done your due diligence on what that specification is. Some people will take it a step further, especially when you're dealing with rehab work. They will actually take smaller diameter drill bits, drill all the way through the slab in a couple of spots. Don't turn the slab into Swiss cheese. Take a piece of pliable wire, make a J-hook in it so that the J is just a little bit bigger than the diameter of the hole. As you push it down in the hole, it compresses that wire. As you push it down and it comes out the bottom, it springs out so that when you pull it up, it's got resistance, so you know when you're at the bottom. Mark the top of the wire with a Sharpie, pull the whole thing out, and you look at where the Sharpie mark is in comparison to where the radius, where the J was at in the wire, and you have a pretty good idea. And doing a couple of spots gives you some comparisons in case there are some huge variances from one end of the building or one end of the facility to another. They do make a device that it's based off of something called Echo Impact, and it works in conjunction with an iPad or any other kind of tablet, as far as I know, and it just sets on top of the concrete and sends a signal that bounces back to give you thickness. I think it's pretty good. I want to say it's plus or minus a quarter or plus or minus a half an inch as far as how close it comes to the actual thickness. And that's great from a philosophical standpoint, but it's still in excess of $2,500 for that device. And so for most people, it's not a practical device to own. Sometimes on rehabs, you're going to find where people are doing some changes in the plumbing. So there's going to be some trenching going on. You can look at the trenching. Usually my basic premise to people is that, especially people that haven't had to concentrate or even think about the thickness of concrete, is that you'd be really surprised once you have it in the forefront of your head that that's something you need to try to determine. You'd be surprised how many times you walk onto a job site with a little bit of diligence that you can find or come really, really close to what that specification is. Okay, well, it looks like I don't have any other questions. So with that being said, again, if anything else comes up, any other questions that you have, please contact me directly. Again, my name is Jason Spangler. Phone number is 800-634-9961, and my direct extension is 235. Thanks, and have a great day.